So earlier on we did the search, which is generally compare. So to expand on that, to move on, in the sort we have to compare. We have to compare one value to the next. If there is a difference, either it's greater or smaller, we swap them. So that's what you're generally doing. So an example would be, say, your utility bill. So if we look at this, we have new electric readings. So every month there's a new electric electric meter reading. So that the data is collected and then it's sent out back to the energy company. They sort the customers. They have to sort them because that data is eventually going to purge and get tied in with the master data. Now the master data is generally going to contain your previous reading. You need to know what your previous reading is in order to know what the bill is going to be. So when it's when the data is taken, it's sorted, and you could say, the databases are far more complex, so it's generally done there and then. So what happens then is it takes the old readings. So this is how it used to be done maybe in the 80s or so. But nowadays, previous data is still kept in the database. So you can track, what was your 2011 December bill. So you could still go back. So it's slightly different. But in this sense, it'll take the last reading and it'll compare it. It'll process the bills. And this is where the swap and the comparisons take place. So the search the swap would take place here, where the data is sorted, and the search would generally take place here, where they're processed. So you need to make sure that the customer numbers match with the master file. So if we look at this example, so there's this example here. So when we go through this list, so generally here we're entering, we input 6 numbers. They're going to be assigned to an array which is called entry. Then we jump into the outer loop. The outer loop. There's also a nested loop. So the nested loop is going to check. So here we have 5 items. It's going to go through 5 times. It's going to check if entry scan is greater than entry scan plus 1. So it's going to test, is the subsequent item greater than the item we're actually checking now? If it is, it's going to swap it. So this section here will take care of the swap. Then eventually it's going to keep moving this item, which may be of greater value than the previous item, and everything just should pan out as being sorted once the outer loop has completed. So there is a CPP file provided, and that does generally the same thing. So when I'm executing, I'm going to enter 6 numbers: 10, 2, 4, 6, 3, 7. And what this is showing you here is the scans that are taking place. So how many scans are there? There is generally 6 scans. So it's the first inner loop, and there's the outer loop. So how many times is I going to perform that? So each time it's moving the 10. You could see the 10 is going to be shifted all the way to the right, and then it's going to take care of the next value, and so on. It's going to keep moving 7 then, and then it's going to move 6, and eventually we get 2, 3, 4, 5, 6, 7 and 10 sorted in order. Now if we move on further, you should be able to track or have a breakpoint just to check what the value is at any particular point. So if we were to run this again, and I'm just going to put I'm going to run this, and it should stop the very first element after I've entered the data. So I'm just going to 3, 4, 2, 6, 8, 1. Okay, and it's actually stopped here. So it tells us the loop. We can always move this around, and then we can pin this. And now you could see the value right now, there is nothing there. But now if we go back, it will show us a sorted list if we continue. And you can see each time the loop is going to increment. And sometimes it's a good idea to put a pin for the outer loop too. So this is with the inner loop and the outer loop. So that this section just displays the data. So it should have been a better idea to put a breakpoint here, and you could check how many times it scans through the inner loop and how many times it scans through the outer loop. It can be a bit tedious if you have a lot of items. Of course, it's going to take you much longer to do that. Moving on, I'd like you guys to do the next exercise. So it's CompuPower Limited, employs well over 500 sales staff that sells computer systems directly to corporate clients. In order to boost employee morale and improve business management of CompuPower, I've introduced a new incentive for the sales staff. Every week, the top 10 salespeople will get a bonus of up to $1,000. It is your task to develop a simple DOS-based application in C++ that will enable a data entry clerk to enter the sales employees, and the system will then sort and print and finally give you the total. So you should be able to do that based on the code you already have. So I'll give you around 15 minutes. So when we look at the exercise, the output should be something similar to this, based on depending on what data you have. So right at the top I have the different variables. I've declared a parallel array, assigned some data into it. Then further down we have, I've just annotated a section here if I wanted to add the data. Then following that we have the swap section. So this is where we have the condition that checks if my first element's values and compares it to my second. That's why we have scan plus 1. If it is less than, then we swap them. That's all that happens. We have this twice because we have a parallel array. We're going to do this with the two arrays. So we have an array of sales and salespeople. So we need to swap both of them. So if I swap this, I need to also swap this, so to ensure that my data is consistent with the salesperson. Then following that, finally, you just output what the data is. And the output is something like that. So this code, we're assigning data into a two-dimensional array, then we're swapping it, or we're sorting it into ascending order. So depending on what we're sorting it against, we could sort it against a sales or a salesperson. So once again, the way this works is it checks, and this is actually telling the total number of sales. So the main part is sales data entry. Here we're actually just switching all of them around, one with the next. So that's all we're doing here. So we have another for loop that's going to take care of our two-dimensional array. So remember, you have a nested loop for a normal 2D array. So that's all we have here, a nested array. A nested loop, sorry. Nested loop. So all this does is when we run this, it'll actually display everything in ascending order or descending order depending on what the condition is.